Good morning, students. Now we are going to discuss about inductive bias. Inductive bias. So already we had a discussion about inductive bias. So whenever we are going to discuss with inductive bias, whenever we are checking with the training data. So if we are going to concentrate on particular data, suppose this is the concept. So in this concept we are going to concentrate on this particular element or these particular data values. So that is the induction bias. So here what we are going to see, so this is observed training example, and this will be the memory. So whenever a new instance is going to be comes into scope, then we are going to verify with the memory. So if it is found, then that will be shown as a result. If it is not found, then it is known. Don't know. So this is the row to learner. And next, so here we are going to discuss inductive reasoning and deductive reasoning. So this is deductive reasoning. So in case of inductive reasoning, what we are going to observe, so it is specific to general, and deductive reasoning is general to specific. So what is specific, what is general? During the last class, so that is a candidate elimination algorithm, we discussed about S0 and Z0. So specific thing and general thing. So generally specific thing is represented with the help of 5, and general thing is we are representing with the help of question mark, right? And here inductive reasoning is logically true and deductive reasoning is logically true, both are true. And here one more statement coming to inductive reasoning, that is may or may not be realistically true, but coming to deductive reasoning, it is realistically true. Suppose there is an example, mango is a fruit, so that means we are going to discuss about what specific fruit, that is a specific nature, and the box is full of fruits. So here again we are going to consider specific nature. The box is full of mangoes, so it is a general thing. So the box is full of mangoes in the sense, maybe that box consists of only the mangoes or other fruits also. So this is it may be or may not be realistic. So that is the thing. And coming to here, all mangoes are fruits. This is a general statement. All fruits have seeds. This is also general statement. And what we are going to consider, mangoes have seeds. This is a specific nature. So this is a deductive and inductive reasoning. And whenever we are going to discuss about inductive bias, so I am going to consider the same problem which we have discussed earlier. So that is enjoy sport problem. And in case of enjoy sport problem, how many attributes we are going to consider? There are 6 attributes. What are the 6 attributes? One is sky and temperature, humidity, wind, water, forecast. And finally we are going to get whether he is going to enjoy the sport or not, that we are going to decide in the last column. So here the sky is going to have sunny, cloudy and rainy values, and temperature is going to have warm and cold, humidity is going to have normal and high, and wind is going to have strong and weak, water is going to have warm and cool, and the forecast is going to have same and change. So these are the attributes which we are going to see with such elements. And whenever we are going to consider the number of instances, so with the help of all these things, number of instances are going to be computed. So sky 3, temperature 2, humidity 2, wind values are 2, water values are 2, forecast values are 2. So total 96. So how to compute the hypothesis? So based on the number of instances, the hypothesis can be computed as 2 to the power of d. So that is 2 to the power of 96. So it is approximately equals to 10 to the power of 28. So like this we are going to calculate the hypothesis. Our assumption was each hypothesis consists of conjunction of attribute values. So that means it may be we are going to include all the attributes. So that is sunny and warm and normal and strong and warm and same. So what is sunny? Sunny is a sky value, and temperature value we are going to consider warm, and humidity value we are going to consider normal, and wind value we are going to consider strong, and water value we are going to consider warm, and again the forecast value we are going to consider same. So here we are going to calculate the hypothesis. In case of this, hypothesis will be calculated as, so this is 1 2 3. So how many values for sky? 3 plus 1. Why the 1? So 1 will be the generalized, so that is a question mark. So that because of that reason 4, and warm cold plus 1 question mark 3, 3 3 3 3, and again 1 question mark. So that is a generalized representation, that is plus 1, total 973. 973 973. So here what is the value we are going to get? 973. So this is the inductive bias. So there are 2 to the power of 96 hypotheses are there. So inductive bias, it is going to concentrate only on 973 values. Clear? So this is the biased space. And here we are going to see the example. He enjoys his water sport when sky equals to sunny or sky equals to cloudy. So whenever the sky is sunny or sky is cloudy, then he is going to enjoy the game. So these are the examples 1, 2, 3, and sky, temperature, humidity, wind, water, forecast, enjoy, sports. So how many positive? There are 2 positive, 1 negative. And here I am going to consider, so what are the values are same? Warm, same, normal, same, strong. So if you look at here, warm, normal, strong, cool, change, so all are same. So again, as it is the specific thing, we are going to say take it as same, but here the only difference, so here I am going to generalize. So this is specific to generalize, and here what we are going to consider, sunny and cloud. So sunny, so so whenever the sky is sunny, then all are generalized. Whenever the sky is cloudy, and so in these 2 cases the person is going to enjoy the sport. So no, sunny and cloudy, so then only the enjoy sport becomes S. So this is the way we are going to define the inductive bias. And whenever we are going to see the inductive bias, what are the new problems we are going to see? So here new problems, more expressible, and but unable to generalize beyond the observed example. Whatever the observed examples, so that we are going to consider only. So beyond that we are not able to consider. So for example, there are 3 positive values x1, x2, x3, and 2 negative values x4, x5. In this case, the specific hypothesis is going to be defined as x1 or x2 or x3, and generalized hypothesis is going to be defined like negation of x4 and x5. So a learner that makes no prior assumption regarding the identity of the target concept has no rational basis for classifying any unseen instances. The only reason that the candidate elimination algorithm was able to generalize beyond the observed training example in our original formulation of the enjoy sport task is that it was biased by the implicit assumption that the target concepts could be represented by a conjunction of attribute values. So here what we have to take conjunction. So whenever we are going to consider the conjunction of the attributes, then we are able to define the whatever the task which we are going to be considered. And the inductive bias, the policy by which the learner generalizes beyond the observed training data to infer the classification of new instances. Whenever the new instance comes into scope, in order to classify that new instance, what we are going to consider, so whatever the generalized concepts we are following, that we are going to consider. And see the here, consider a concept learning algorithm L for the set of instances X. So this is a concept learning algorithm. What is that? L. Let us assume L, and number of instances, that is X. Let C be the concept. It will be defined. So this is the training data. So X of C of X be an arbitrary set of training examples of C, and classification assigned to the instance of X. So here what we are going to see, if you look at this, for all X belongs to X, and whenever we are going to classify the things, so what we are going to do, so L is the learning algorithm, Xi is the sample, so D is the trainee data. So here Y is provable from X or Y follows X. So this symbol is this one. So what is this symbol? So Y is provable from X or Y follows X. If I write like this, what I need today, Y follows X. So for all X belongs to X, B, D, Xi. So what we are going to consider the training data, instances, and B. What is the B? B are the assumptions. Assertions are assumptions. Whatever the assumptions we are, how before going to evaluate the task, we are going to assume. Suppose this maybe belongs to that particular class. So that assumption also we are going to consider. So based on the assumption, based on the data, based on the tuples, we are going to define the inductive bias, and we are going to define the classify the things. So here if we are going to compare three rote learner, candidate elimination and Fine-Dice algorithm, so the Fine-Dice algorithm will be the strongest inductive bias, and candidate elimination will be the stronger inductive bias, and rote learner we didn't find any bias, so that is a no bias. So we didn't find any gap between the specific and generalized, so because of that reason, so this is a no bias. So in case of Fine-Dice algorithm, so it concentrates only on positive values. The most specific hypothesis consists with the training example, and in case of candidate elimination, we are going to consider the version space, and here we are going to use positive and negative examples. So this will be the stronger inductive bias. So this is about inductive bias. Thank you.